Okay, so today we're talking about the graphs of the functions sine and cosine.
He's like Mariah.
And here's...
Mariah is not cute. She's the worst.
Oh, okay.
She's stricter than... Who's the strict teacher? Mrs. Stanley.
Mrs. Jordan so spread out. No one can compare them.
Okay,
Drew, he's right there.
so we're looking at the sine and cosine functions on a graph. So cosine of x or theta or whatever and sine of theta, the values kind of oscillate, I think that's the fancy word, between -1 and 1. I go back and forth between those two. And whoops. And you know how every 2 pi it starts repeating itself, like on the graph? So the graph starts to repeat itself. Okay, anyways, I should have spread this out more. Here, we'll do this. Alright, here's what it looks like. This is the sine of theta. It starts at 0. Whoops.
I'll do that at you.
Okay, and then it keeps going after that. But at 2 pi, see where it's kind of back where it started over here? So every 360 it kind of starts repeating itself. And it goes on like that forever. And over here in it looks the same.
Is that called the mode?
The mode? No.
What's it called? Like
The period?
yeah, period.
There you go.
You're in a period.
Drew.
My bad.
Alright, let's see, what was I talking about? So yeah, when it starts repeating itself every 2 pi, that's called a period. Every 2 pi it looks the same. Cosine, should I put it on the same graph?
No.
It's almost identical. You're gonna make me draw the whole thing again?
Yes. No, I'm nice. I'll let you.
Unless you make it another color.
Oh, make it purple.
I'll do another color in
That's not purple.
2, 3, 4. I just won't label it all. Cosine starts at 1, so instead of starting at 0 going up, it starts at 1 going down.
Whoa, that's spicy. Wait, why?
Wait, what?
It just does.
Oh, because it starts at
Why would it?
90 instead of 20.
Because at 0 degrees, cosine equals 1. That's just how it works. And then at 90 degrees, it equals 0. At 270, it equals -1. Anyway, this is just another way of looking
This
at
is like a
it.
function for the circle.
Why
but
do we
like
need to be able to do this?
Yes.
That's tricky.
Sometimes trig functions can map patterns like any function. Any function's real life, or any graph's real life use is just to make a picture of a situation that you can use to like predict the future and that kind of thing.
Graphs can predict the future.
Yeah, basically.
Wait.
They can be wrong a lot. Like, you know, when we
Wait,
had
yeah,
on the COVID thing, they're like, okay, this is what it's doing now, so it should do this, and then this, and then they're almost invariably wrong. But if you get all your variables right, you should be able to predict the future. Yeah.
But,
I mean, you know, not just COVID or money or population or whatever, that kind of thing. Like the one problem that I remember with this is like the tides, you know, they go up and down. So this kind of maps the tides, level of tides. Anyways, okay.
So what did the tides do before the government made it?
yeah.
Hmm?
Like before the moon was invented by the government, how did the tides do? Did it just stay at the same spot?
No, the moon doesn't actually affect the tides. That's just what they want you to think. They always did that. They just do it. They just feel
It's
like
just them
What
sucking the
is
salt
this?
out of the ocean and then refilling
If
it
you're
with
trying to
water.
make sense of it, you're wasting your time.
That's the master plan of the government.
Okay,
They weren't
The
going
mess
to
of
what do you guys,
was
so-
using 5G towers to give us COVID and then drag us to the vaccines.
this is the graph.
Do we need to draw that? Like memorize that?
No, not really. It would be helpful if you remembered that the normal period is 2 pi before it starts repeating itself, and that sine starts at 0 going up, and cosine starts at 1
Was the
going down.
5G created whenever COVID was created?
Yeah, kind of freaky.
Okay, guys. This is the graph of y equals sine of x. Guess what would happen to the graph if I put a 3 right there?
It would go up.
It would go this way through.
It would
Why is it
fluctuate
short?
with frequency.
Okay.
It would be between 3 and -3.
That's right. So it's going to be 3 times taller, basically.
That's what it's.
So instead of going up to 1, it would go up to 3. Instead of going down to -1, it would go down to -3. So I guess I can maybe draw it a little bit.
Hello?
That's pretty good.
Do you guys see it? Okay, so at 0 it's still 0, but what do you think would happen if I put like a +1 up there?
Would it?
That's
It goes up one, down one.
Up
No.
one, down
It
one.
would get
Left,
It
right.
would get
Wait,
Bigger.
left one.
It goes up 1, so it'd be like that.
That's what.
That's what I said. Let's go.
You guys should know. Those are old tricks, right?
Yeah.
Yeah.
The 3 was kind of newish, a little bit, but yeah, the
Because
+1.
if it's in the parentheses, then it goes up.
Right. We're not doing in the parentheses stuff today, though.
One of that was on the P set.
He said.
It was like
P
one.
set?
It was like in a parenthesis and then one not, and it was like
The one in the
Where's the
parentheses
graph?
affects the x motion left and
Yeah.
right, and then this one affects the up and down. We're not doing anything directly on the x today, but we will. Like if it was like x minus 2, this would go up 1, right 2. Does that ring a bell?
yeah.
But we're not doing this today. All right, we're just doing this.
Why not just throw that in?
Well, we got enough on our plate.
I'm confused.
Yeah.
Where?
How does that work? The red one.
That's for you.
This moves it right 2.
Yes.
So like,
So we're gonna need that today.
no,
Throw
I
that
said
in
not
the
today. I think it might be the next one, yeah. So if I put a negative up front, you guys remember what that did?
Absolutely.
Flips it.
Flips it.
Upside down.
Flips it. I bet there's a flip thing in this.
You can just turn it. If you grab that little green circle right there,
See the little thing?
that works too.
Oh,
Whoa. Oh, what?
moon roasted.
Where are you? Oh, bye.
Hi.
Bye. Have a great time.
Okay, you guys ready? We're doing page 005, numbers 1 through 16.
No.
Where are you?
Oh, wait, this is
Is it-
the
do we
only.
know-
Numbers
on the
1
graph.
through 10 is graphing, the rest of them is not.
Wait, 1 through 6. Oh, that's
It's a good thing. I was doing 1 through 6.
Okay, I forgot to define a word. So, you guys remember what I said the period was?
Yeah. How often it repeats.
How long before it starts repeating itself? Normally, it's 2 pi. Oh, there is a number on the x on some of these, but it's not added number, it's a multiplied number. Darn it. That makes,
We're gonna skip that.
that's the hard part. No. The other word that I forgot is called the amplitude.
We learned that in science.
How
Okay.
far away from
The amplitude is used in a lot of different things.
Oh.
The amplitude on a periodic function like sine and cosine is how far it moves away from 0. So, in other words, this goes up 1 from 0 and down from 0, so the amplitude of a sine, normal sine function is 1.
Why would you use the same word for
Okay, the height of the function, if you look at it like this, is 2, right?
Yeah.
But the amplitude is just 1. That's how far it moves up and down from the center.
So amplitude is height divided by 2 then?
Yes, basically, the height divided by 2 is the amplitude, yes.
Wait, where? For number 1, are they all the same?
The height is 2,
Okay.
but the amplitude is just how far it moves from the middle,
Which
which
is
is 1.
okay.
So like if it went up 1, the amplitude would be like 2.
You mean if it was twice as tall?
Yeah. Not like if it was like.
So basically, when you put a 3 up there, since it makes everything 3 times taller, the amplitude's going to be 3.
But it's
Like if you
it's
add the
six.
1.
Right.
No, well, the height would be 6, but the amplitude's just 3.
Like if you did multiply by 3 and you just added the 1.
If you add the 1, that doesn't change the amplitude, it just moves the graph up. It's still, that probably won't work.
Because isn't that 2 away from 0?
It's not how far it is from 0. If I said that, I said it wrong. It's how far it is from the center.
Okay, that makes sense.
So it's still 1.
So would it just be the height divided by 2?
Yes.
Okay, that makes sense.
Why you still smart though?
Wow, how'd you get that?
Yeah.
If only Drew was that smart. He's not though.
Man, yeah.
Don't worry, dude. Just
Too bad.
apply yourself.
Too bad.
Okay,
Just apply.
number 1.
That is the most.
We are sketching stuff.
It's only annoying because you're not smart.
Do you guys want colored pencils?
Yes.
I want
Yes.
Because we're doing 3 on this.
Coloring?
We're doing 3 on the same graph.
Anybody
Actually,
have the skin colored
would I
pencil?
get extra credit if I
Skin
brought,
color.
if I brought my own colored pencil?
Growing up, I
It's
never had it.
racist.
Growing up, I never had like a skin color.
Now I saw them at Walmart and it was like skin colored pencils and it's just like canned and round and it's all it is. Like there's no blue or red, it's just skin colored.
That's weird.
What about onions?
Like what?
Do people actually buy crowns that are just tan through
I guess.
brown?
It was a pack of like, I think it was
If you
10.
want to teach your child race equality.
Racial equality?
It's not race equality.
Yeah, I meant
You're not
like, do you
racing.
get like how many
We're racing.
colors?
All races are equal.
We try with
This-
South Mark.
What I keep saying.
Right now,
This is the most
What did you say?
useless.
I said all races are equal except for that.
How many?
Except
This-
for what?
The bad.
Yeah.
No, we're all equal. It's just Mexicans are more equal.
Some are just more.
I need to get the pencil sharpener out.
Is that
This is the most
Oh,
useless.
wait, I actually-
You guys
I
need
ever
to
come
read more
color in the
Yes.
whole
Markers
thing.
are gonna be too thick.
I'll
You know
never
why?
read that book.
I'll make a
That
mess.
book is fantastic.
Anybody else want one?
Just 3, right?
That's a good.
How many colors?
I didn't get any color.
We're doing 3 graphs, so we probably want
I
3
didn't
colors.
get any
3
I
lines on the same
I need
graph.
to segregate this one here.
Get the black one away
My
from me.
water is some weird colored pencils.
Yes, sir.
My
Thank you.
Hey,
I
Jack.
need to create a hierarchy of which colors are the best.
White is always the best.
So white will be over here, along the flag,
That's not.
along.
Okay.
Let's get peach.
Louder.
What? Oh, get peach. Probably blue is better because blue is like my favorite color.
I didn't see that.
If you want to make your graph really neat,
No, I'm good.
actually, we go to,
Yeah, we know.
I'm good.
Let.
What's
Let
that?
Yeah.
You really need to start applying your stuff.
You
I know.
hey,
Know what I mean there.
if you want to make your graph neat, you might want to, like, skip some lines here, like, count by 2, 1
Are we counting by like integers?
One.
Okay, so for the x-axis, it'll be now I'm getting annoyed. For the x-axis, it'll be a lot easier if we use like pi over 2. 90 degrees, 180, 270, those are better. So I'm just going to call this pi over 2, which is like 90 degrees. And this is pi, and this is 3 halves pi.
What is the skip line?
And this is 2 pi.
How big do you think that the graph should be?
If you do like I'm doing, you would need to go up 6 and write 8, I guess.
I did 3 and 4.
So 16?
Oh, I did not do that.
It's you don't
You
have
get a
to,
haircut.
you don't have to do it my way.
Me? Yeah.
It's
that's a
16
while.
by 8?
No, it's yesterday.
If you're using my method, yes. It's 6 tall, 8 to the right,
I said
6
never.
down, 8 to the left.
It does look
Is
shorter.
that sad?
Did you straighten your hair?
I did.
That's probably it.
Oh my gosh, how observant. Like, men aren't that observant.
Hey, that's racist.
That is
We
sexy.
all-
Because he's Indian.
I've never been asked about my hair.
You know what? Don't ever talk to me again.
Not from a guy.
You have hair.
That's what it is.
When did you get that?
Okay, So cosine, that's what we're graphing first, so pick your first color. If your graph looks something like mine, you should start at 1. By the time you're to pi over 2, it should be at 0.
Do we have to label it, or can we just,
Yeah, you need to label something.
So
If
one
you
is
just
like
want to
2?
put, if you want to put 2 pi on there, that's fine.
Why is 1 2?
how far?
Like why is y 1?
Because if I make it 1 tall, it'll be like tiny.
Oh.
Yeah.
And we're kind of like zooming in. At pi, it should be down to -1.
That's nice.
So I'm gonna put it. Maybe it'd be easier just to put the dots in and then connect the dots at the end.
I
Probably.
love connected dots.
Once you get to 3 pi over 2, it should be back to 0, and once you get to 2 pi, it should be up to 1 again. So about like that. And then repeat. I'm just gonna put the dots on the back side. So at negative pi over 2, it'll be there, and then there, and there, and there.
Wait, how did we figure that out?
What?
It's not something you figure out. It's just something you can memorize, I guess. But. So this is what cosine looks like. At pi over 2, it's down to 0. At pi, it's down to -1. At 3 pi over 2, it's back up to 0. At 2 pi, it's back up to 1.
I'm proud of this. Would you look at that?
Did you look at that?
It's lovely.
I worked day and night on this.
Okay, and then the second one is we're graphing 3 times cosine of x. So what did we say? That's like exactly what.
What's the color that?
Well, it already is. There's nothing to color.
Well, like, in the color.
What?
No, like,
Okay,
go.
So remember when you do 3, I don't know what you're saying. When you
This
do
is not
three,
number
We have to
one.
draw the line
This
in
is
the
number
color.
this is number 1. Number 1, we're also supposed to graph y equals 3 times cosine of x. So,
This assignment is gonna take over.
So is that what you're asking? Get another pencil out? Is that what you're saying?
Yeah.
So if it's 3 times, it's going to be 3 times as tall. So I'm going to go in and put my dots. At 0, it's still 0. So it should look about like that.
Should we have not put that in color?
No, that's fine. Yeah, I did it.
Imagine not putting it in color.
Gosh, I did put it in color.
Oh.
Should look like that. And I'm going to do the mirror image on the left side.
I already know this is not gonna go the one I'm trying to do this.
I just realized my pencil is the same color as like the lines on it.
Do you do blue?
Yeah.
Yeah, I do blue too. Blue's my favorite color. That's cool.
Whoops, okay, I screwed that up.
Sorry about that.
White is my favorite.
Yeah, just favorite color.
Drew, you're my favorite color.
That's racist.
Because your last name's White.
Dang. I love whites.
Okay, then it says 1/3 cosine of x. So guess what that's going to look like?
It goes up 1/3.
It's going to be 1/3. Yeah, it's going to go up to 1/3 and down to -1/3. So
Orange.
pretty short, pretty flat.
Kind of like
That too?
I don't like where this is going.
Yeah, you're making me nervous, Josh. For some reason, I don't trust your judgment on saying appropriate things.
why?
I don't know. It's weird.
I think you get it because David says.
Yeah, yeah, good David.
It's not because of me.
No.
Why are you the same color?
Wow, they're using the same color.
At least I am colored.
Kind of miss there.
What?
I said solid from there.
Oh, did Mr. Odell talk to you or anything?
Oh yeah. He
Okay.
told me to send you those things.
I sent Kate the photos.
Okay.
Braden will be playing drums at a week.
Okay.
Wow.
I
It's
don't
like
remember.
ridiculous.
I don't remember crowns being colored.
What?
Are you you serious?
I don't remember crowns being called skin color.
No, like as a
There
kid,
was peach and tan, and those were like weird.
like as a kid, did you ever
And
like,
those were like,
hey, Nathaniel?
If you had to color somebody's face, that was
Aren't you ever like, hey, Nathaniel, can you pass like the skin color?
I'll be the tan. Past the tan one.
Yeah, but then
it was called tan.
some white kid asked me to pass him.
Tan is
skin
opposite
color,
over hypotenuse.
so I gave him the
so.
brown.
brown one. Yeah, and he goes.
Why does
"I
it
don't
not
see
like
it."
actual color? So like the green is the answer to number one?
All three of them are the answer.
Brady gets really mad.
See,
when you say
one of those, one of those.
Crown
Crown?
instead of crayon.
Isn't it pretty?
He's like, it's not a crown. It's a crayon.
Sure.
That's fair.
Like that, you know?
Okay,
Next one.
number 3.
What's wrong with you?
You guys ready? Still moving? What's going on here?
Side.
For now, Dale. He will like stop you. He'll be like, what'd you say?
Okay, this one we're starting with sine of x. You guys remember where sine of x started?
At 0.
At 0. So,
This is 3.
yeah.
Is the graph the same size?
Yeah.
Oh, dear Lord.
Sine of x and cosine of x are almost identical. Sine of x has like a 90-degree head start on cosine of x. Anyways, so it's going to start at 0. At 1, it's going to be up top. At pi over 2, it's going to be up top. At pi, it's going to be back down to 0. At 3 pi over 2, it's going to be down to -1. And at 2 pi, it's going to be back up to 0.
Do we have to do the pi in all of them?
If you just want to put like a 2 pi there, that's okay.
Okay.
But it doesn't need to be labeled a little bit. Just,
So just the 1, 2, 3, and then 2 pi all the way out there.
yeah. Maybe to help yourself, maybe put like a pi and a 2 pi. Pi, yeah. Anyway.
So pi would be 4 over.
Yeah, if you use my method, yeah. We could count by one. So like we could use, I could have put pi over 2 here and pi there. It would have just been very,
That's what it did for the first.
it would have been very small. And then just do the mirror image on the back side.
Hey, Shawty.
Well, actually, it's not a mirror image, but it's, you know,
It's your birthday.
like that.
Ooh. That's a problem. Ooh. What if, is it okay if we end up there?
Up where?
There. Instead of going back down.
Oh yeah, that's okay. Not that picky.
You never know.
You did get in trouble for not drawing lines though, so.
Arrows.
Arrows, that's right.
I remember that.
That was-
An arrow every single time since.
He's traumatized from that experience. Alright, and then we're supposed to do,
Are you okay, Matthew?
okay, this one's actually different. Do you guys see where the 1/2 is written on y equals sine of 1/2 x? Whoops, what am I doing? So on number 1, the 3 and the 1/3 were written in front of cosine, right? So it made it 3 times as tall or a third as tall. So on this one, the 1/2 is in front of the x. And so what it does is it squishes.
It squishes.
Everything is happening.
Twice as fast.
Is there
Half-
not a
half-
graph for
Wait, no, it stretches. Everything happens. So,
Is that
yeah, because if this was 90, that would be like 45. So that would be,
It would just be 1 on the graph.
90 is like 45. So it'll be, yeah, I was right first time, it squishes.
So it goes faster.
Yeah.
So, but it's the same thing.
Yeah, so, okay. No, that was right the second time. It goes half as fast. Okay. So it doesn't get up to 1 until all the way over here at pi.
That's nice.
And at 2 pi, it's only down to 0. Yeah, so let's just think of it as everything's happening at half speed. We'll think of it that way.
It's slow.
Oh yeah, that makes sense. Okay.
So it doesn't go under?
So it goes under, but it'll get back to -1 on the left side. It'll get down there. So it's kind of like that.
Bless you.
Is there a graph for tangent? Or is it just?
There is a graph for tangent. We're not doing it. It's weird. It's like that.
For tangent?
Yeah. We're not going to be graphing that one.
I see.
It looks like a bunch of those over and over again.
Oh, that was cool.
Alright. Did you guys get it?
What
Yes,
about color
sir.
green?
There's only 2 graphs on 3.
Oh wait.
So on 4, that's going to be challenging. When it says y equals cosine of 3x, everything's going to happen 3 times faster, so it'll be squished, horizontal squish. So when you go to label it, maybe I should help you set that up. It will be easier. You can kind of cheat in a way. So normally this first one I label pi over 2, but if you label it, if you divide pi over 2 by 3, you'll get pi over 6. So every step would be going up pi over 6.
What?
It might not be the best idea.
Can we not do it?
No.
I don't understand your logic at all.
I'm trying to think of the easiest way to do it.
Don't show size real quick.
So we get sin of
You literally.
2/3 x for 3/2 x
What are you talking about?
for number 5.
Oh, I'm thinking about number 4. Yeah, I don't think of a good way. I mean,
Wait a minute.
let's come back to pi over 2 again.
So if it's by a whole number, it becomes squished, and if it's by like less than 1, it's
Slows down. What a mess. Alright, I'll just do that later. Let's go back to
So no
number
four.
5. No, you're doing 4. Okay, what?
What about a negative number? Like it doesn't work.
it just flips.
Negative flips it upside down. So on number 5, it says give the amplitude and period of each function. So do you guys remember what I said the amplitude would be for that one?
For which one?
And sketch its graph. Maybe we should sketch its graph.
Boo.
No, we'll do a second.
Yay.
Okay, it says y equals 2 sine of 3x. Okay, you guys remember what the 2 did? Made it twice as tall, right? So the amplitude on this one is just going to be a 2. So that's part of the answer. So let's just put a equals 2 amplitude. Okay. This period, I remember this from last year. What did they use? What did they use?
2, where did we get that? Wait, are we keeping the same? Wait.
We still have to graph them too.
Okay, so yes, the period is normally 2 pi, right?
Yeah.
But if you put a 3, everything's happening 3 times faster. So the period is going to shrink. Like everything gets squished like this. So it's going to be a third of 2 pi. Does that make sense? So you just take this number and go put 2 pi over 3. Does that make sense? Basically just going to be, normal period is 2 pi. If there's a number in front of the x, it's going to be a third as big as it normally is. So it's 2 pi divided by 3, 2 pi over 3.
So if that number was 4, it'd be 2 pi over 4.
Okay, now I remember how we did this last year. Yes, yes it would be. Or 2 pi over 4 reduces to
Like,
pi over 2. Okay, I remember how I did the weird periods last year. So we cheated. Josh, I don't know if you were here or not. How we cheated was instead of like making the graph fit into the 2 pi thing, I just said, let's put 2 pi over 3 right here. Well, right here, where the 2 pi used to be.
Does it just go all the way over?
So if you change the period, if you change the x-axis, the picture kind of remains the same. Does that make sense?
Yeah.
So normally the period's 2 pi, that's right there, and then we just, kind of map it out there. But if we change it to 2 pi over 3 right there, then we can still do the same graph. It's just, we're kind of fudging with the x-axis to make it look prettier.
so does that mean the same numbers as the regular ones? Like the pi over 2?
It's gonna be pretty normal. So the halfway point would be like 2 pi over 6, which is like pi over 3. So I'm using different x values basically instead of the ones we used last time. But we can still use like these reference points. Okay, the amplitude is supposed to be 2. So if I use my same thing from earlier, it would be like this. Go from here to here. Okay, so it's a sine function, so where am I starting at?
0.
0. So on my first point right here, it'll be up top. Pi over 3 now instead of pi, that's what it used to be. It's back at 0. And stuff like that. Well, I just replaced my 2 pi, the new period 2 pi over 3.
Why do we need to do that?
Because it's hard to line it up otherwise. I could use 1, 2, and 3, but 2 pi over 3 is like 2 point something, and that would just make for a real messy graph. So if I just choose my points so that it's like where the period repeats itself, it just lines up nicely. Otherwise, if I put 2 pi here, well, it'd be like, where's pi over 3 at? It's like right there or something in the middle. So it just makes it easier.
And so like the period is always the number before the x over like.
This is the amplitude, yes. This is the amplitude. The period normally is 2 pi, like if you don't mess with it.
Okay.
But if there's a 3 there, it's happening 3 times faster, so the period is a third of what it was. So that's why it's 2 pi over 3.
Okay. And
Basically, you do 2 pi divided by that every time.
Okay. So like if the number was 7, it'd be 2 pi over 7.
Yes. Yeah, last year I tried to write this as a formula, and the formula just always confused people. So I think it's probably better to just think of it. Normally it's 2 pi, so just do 2 pi divided by 3. All right, and then I'll just do the mirror image over here. But I have the one solace that I get to mark up your papers with a lot of red ink.
Yeah.
Care about your well-being.
Wait, we didn't do the second. Oh, amplitude.
It's mutual, sure. Okay. Thank you so much. Number 7. Okay, what's the amplitude on number 7 going to be?
Whatever I feel like.
Nope. 2. The negative doesn't really matter as far as amplitude goes. It's still going to be 2 up and 2 down. And the period, I'll just put PER, is, okay, what, you guys know what it's going to be? Ignore the T, that's just our, it's like the X value, but the period is going to be 2 pi over
Wait, this is
2.
7, right?
Which is
Number 7. 2 pi over 2. 2 pi divided by 2, which simplifies to pi. So basically, everything's going to happen twice as fast. But I'm still going to put pi way out here instead of 2 pi, so I can spread things out and see it. I'm just putting the halfway point to just kind of help myself. Okay, where does cosine normally start?
1.
Up at 1. But this says negative 2 cosine. So it's going to start down at negative 2. It's upside down, so it's negative 1, but it's also twice as tall. So it's down to negative 2. Oops, I put that in the wrong spot. There we go. So this is where we're starting. By the quarter point, we should be back up to 0. At the half point, we should be up to 2. And we should take it back down to 0.
So the period was pi?
Yes. It's 2 pi divided by 2, which is pi.
Yeah, I don't like the system.
I don't like it either. Is this a 2-day?
Yeah.
Are you kidding me?
It better be.
It better not be.
Shut up,
It better
Josh.
yes be.
Yes, sir.
Thank you.
You should have said make me.
I only said that when I flirted.
Ooh, that's me. To Jackson, not me.
You ever flirt with me, Josh?
Always. I don't think I don't flirt with you. That's
Jo-
cute.
Josh, I don't think you know
You
how to
should
flirt with
stop.
anybody.
I don't flirt with Mr. Jordan.
Don't even say that. Puke. All right.
I didn't think so. I didn't think that one.
I think he really does, Josh.
Okay, on oh, are you guys done?
No.
No. Wait.
This
After 9, we can be done.
is another value too.
Watch your mouth.
This is poopy. Josh, this is
Why do you have a
Give me a half.
hourglass on your necklace?
Cause it's my necklace.
She thought it was
Because it's my.
Yeah, he thought it was my grandmother's ashes.
No, no, I didn't.
Yes, you
I
did.
said it
You
looks
literally-
like somebody's ashes.
Her grandmother was
Yeah,
a
that's the nice thing to do.
was an aunt.
What?
Your grandmother was an aunt.
Ooh.
A-N-T.
Yeah, like, I get it.
You mean aunt?
No.
Okay. Number 9. What's the amplitude on number 9 going to be?
So he doesn't mean aunt?
What's the amplitude on number 9? 1/2. Just the number in front. Okay.
I like it.
The period.
Shut up.
The period. Okay, the period on 9 is going to be 2 pi divided by 2 pi.
So 1.
So 1. But I don't want to put 1 right here because I don't want to do this.
Why
I
not?
guess you could, but then you'd have all that stuff. Because it'll be easier if I just put 1 out here. So 1, and then a half would be right. Wait, 1, 2, 3, 4. Right. There, that'll be my labeling.
Oh gosh.
Okay, so
1/2, right?
cosine starts where normally?
1.
Starts at 1. But if we're multiplying by a half,
Just a half.
it's going to start up at a half. So at a quarter of the way, it'll be back down to 0. At another quarter, it'll be down to negative a half. At another quarter, it'll be back up to 0. And another quarter, it'll be back up again.
What?
Can't keep them down. Just think of this in fourths. Like after 1/4 of the period, it'll move 1 down, well, 1/2 in this case. At another quarter, it'll move a half an inch. Another quarter moves a half. Another quarter moves a half. Does that make sense?
Kind of.
Like it goes from top to middle to bottom to middle to top to middle to bottom. That's the pattern. Yeah.
That makes a lot of sense.
Lots and lots.
Oh, I've been writing down the
Oops.
amplitude.
Oh yeah.
No, I did that right.
So what's the period on this one?
1/4. Where the 1 is 1.
Period is 1, right?
Oh, so the period is every time it cycles?
Yes.
Okay.
How long until it repeats?
Can we do number 4?
Well, now that we've done that, number 4 is going to be a lot easier because I had to reboot my brain on how we set up the period. We kind of did number 4 on number 5 in a way because 5 said sine of 3x also. So on number 4, what's the period going to be for the second one? On number 4. Oh, but you got to do it in the same graph. Yeah, it screws it up.
Oh yeah, I already.
Alright, I'll just do them.
Yeah.
I can't think of an easy way.
Really?
Well, you guys know it. Well, the problem is we have to put cosine and cosine of 3x on the same graph, right? So I'm just going to use the standard 2 pi
That's
period.
what I did.
Good for you, Josh.
I am kind of special.
What?
Okay, cosine starts up, right? So we're going to start up at 1, go down, down, up, down.
Number 2 looks pretty cool.
Okay.
Number 2.
Looks
It
like
looks like diamond.
Is that number 4?
diamond in the rough.
That's the cosine of x for number 4. We still have to
You
do
think
this
that's my phone?
cosine of 3x.
You think I read
Can
that
I get
phone?
out the other?
Actually.
Yeah.
Okay,
She always asked me how it's going.
This D.
here's the thing. Cosine of 3x, it's going to finish 3 times, the period is 3 times faster, or a third of the length. So this is like 8 steps over, so we need 8/3, which is like 2 2/3. So it should finish up the period by right here. So it's going to be like that.
That's it?
No, well,
Oh,
Gosh.
this is why I was having trouble, like how we're going to set this up. And then after that, you need to do 8/3 times 2, which
can't you just add 2?
2 2/3 plus 2 2/3. That's another way to do it. So that would be what's 4 and 5 and 1/3. Let's see, 3, 4, 5, right there. That looked like it split up into thirds there.
I don't know how to place.
So okay, my first dot,
You get 5 and
I have moved over 2 2/3.
2 and 2/3.
Yeah. it would be, yeah, 1 1/3, yes. See what a mess this one is. They were stinkers on this one. So it should look like that, except for not quite that slow. It gets through 3 periods in the time that the red one got through 1 period. And I'll just do a mirror image on the back side. Looks a little sloppy Joe in the middle.
Okay, mine's really
Mine's not, so.
good job.
Junk in my
No, I quit.
I
wish that you could just, like,
Jackson,
you know.
I didn't get that
Monday
blue one.
notice, and I want.
I didn't get that blue one.
Like everything else.
I
is
can't
blue.
With the
do
way
two
that you
weeks.
spaced them out, the way that I did mine.
Okay, yeah, I try to do a third of this thing, and then 2/3 of that thing, and I just try to split it in half right down here.
Are you gonna work this on this tomorrow, or is it just due?
Working on it tomorrow, of course.
Yeah, sorry.
No way you guys could do that.
Oh,
It's Wednesday too.
That's church day.
That did not stop 2 other teachers from giving us this.
Oh, and then I got that freaking paper here.
Bro, this is a.
What's your paper?
Well, it was actually due today, but I didn't get it done.
Oh, the Bible paper?
yeah.
Yeah.
For
I
the
have the
last
papers.
hour, did you actually get through all the icons on the YouTube thingy?
This
I know you
is
just
your,
watched the video to like jump.
Yeah.
Did you hear them convince me that we had a
So are you gonna
paper
take the
today?
test tomorrow?
Due today?
He convinced Mr.
I'll
Smith that
attempt
he gave
to.
us
I
the
don't,
paper
yeah.
today.
That was
I'm
actually
gonna
should
just
come in
get it
with-
over with.
I was scared
rather
that
than,
Maybe you
like,
should come in
having-
and start for the test.
He was like, oh, I'll get that for you. real
So
quick.
we told Chase, there's a paper due today. He was like, are you
Study for the
serious? You know, like at first I thought we were
Like based
kidding.
on
We
the
actually were,
activity
we could fix it anymore.
I like it out.
So then he was like, okay, well I was gone when he assigned it.
Okay.
Yeah, so then he goes, hey Mr.